Hello students, welcome you all in the next video session of Maths 2. Today we will be seeing lesson number 8, Trigonometry, Introduction and Exercise 8.1. This is a very new concept to you all. In Standard 9, many new concepts you have seen. Trigonometry is among that. First, let us see what is the meaning of trigonometry. Trigonometry, if we break in three parts, it will be trigonometry. Tri means three, gono means sides, and metry means measures. Altogether, it means three sides measure. Three sides we know is of triangles. In this slide, you can see a special type of triangle, that is a right angle triangle. Here you can see right angle triangle PQR. When we see the right angle triangle, we immediately recall Pythagoras theorem. Yes, trigonometry is related to three topics. One, right angle triangle. Second, Pythagoras theorem. And third, similar triangles. Let us see how trigonometry is useful in day-to-day life. In this slide, you can see a picture of tree. Nobody can take a scale and measure the height of the tree. But yes, that is possible with the help of trigonometry. You will ask me how. If you see the slide very accurately, you will see the height of the tree, the distance of that from a man, and top of the tree to the man is made a right angle triangle. If this same right angle triangle I make on the ground, there are two right angle triangles. We already know the similarity of triangles. If we make the ratio of this, the triangle which is made by me, we know the measures of that. In the similarity, we take the ratio of sides. And using similarity of this, we can measure the height of the tree. Trigonometry is also useful in aviation or flight engineering. You must have visited a coastline. There, lighthouses we observe. When we build the lighthouse, the height of the lighthouse we know. From lighthouse, what we do? We keep the watch on ships. Ship in the sea is how far from the lighthouse we can measure with the help of trigonometry. In this example, you see this is the lighthouse. The ground line is the distance of the ship from it, and from top of the lighthouse we can keep watch on the ship. This makes a right angle triangle. With the same example, we can take help and use the trigonometry to get the distance of the ship from. Here we will start studying actual trigonometry in standard 9. You can observe a right angle triangle here. Three sides are named by adjacent side, hypotenuse and opposite side according to angle A. Sine, cos and tan. Sine, cosine and tangent are the three basic trigonometric ratios. Today, with the help of this example, we will study it. What do it mean? First, let us see the sine ratio. Sine ratio defined as opposite side upon hypotenuse. Cosine means adjacent side upon hypotenuse. And tangent ratio means opposite side upon adjacent side. Here we are going to start the actual trigonometry for standard 9. You can see a right angle triangle and the sides are denoted by particular names. For angle A. For angle A, adjacent side, opposite side and hypotenuse. Sine ratio is denoted by opposite side upon hypotenuse. Cosine ratio is denoted by adjacent upon hypotenuse, and tangent ratio is denoted by opposite upon adjacent. These are the definition of these particular ratios. Sine, S-I-N-E, sine, in short we can write by S-I-N, sine. Cosine we write only cos. Tangent we write only tan. In this slide you can see the clear picture of sine, cos and tan. Sometimes to denote the angles we write the measures of acute angles of a right angle triangle by using Greek letters theta, alpha, beta, etc. In this slide you can see the angle C is denoted by alpha. For angle alpha, opposite side, hypotenuse and adjacent sides are mentioned. For angle alpha, opposite side is AB, adjacent side is BC and hypotenuse is AC. We all know that hypotenuse in right angle triangle never changes. So, for these same ratios we denote for angle A, then opposite side will be side BC and adjacent side will be side AB, but hypotenuse will not change. So let us come back to sine ratio. Sine alpha, as we know, it is opposite side upon hypotenuse. So in this particular example, it will be AB upon CA. Cos ratio, as we know the definition, is adjacent upon hypotenuse. So in this example, it will be the ratio CB upon CA. Same way, tan alpha is opposite upon adjacent, means it is CB upon CA. In the same example, if we take all these sine, cos and tan ratios for angle A, so how the ratio changes? Let us see. If for angle A, opposite side, as I say, it is BC, adjacent side will be AB and hypotenuse will be AC as it is. So sine A will be opposite upon hypotenuse is equal to BC upon AC. Cos A adjacent upon hypotenuse will give you AB upon AC, and tan A will be BC upon AB. Here is the first example of exercise 8.1. Figure PQR. In the given figure, angle R is the right angle of triangle PQR. Write down the following ratios: sin P, cos Q, tan P and tan Q. First, let us see sin P. So, for avoiding mistakes, we are concentrating on P. So, for angle P, opposite side will be what? It's RQ. For angle P, adjacent side will be what? It is PR. And hypotenuse will be PQ. This way, we can fix the images in our brain and then start writing ratios. So, sin P will be opposite side of angle P upon hypotenuse, that is QR upon PQ. Next ratio we want to write is cos Q, means we want to concentrate on vertex Q or angle Q. So for angle Q, opposite side is PR, adjacent side is QR, and hypotenuse doesn't changes, it is as it is PQ. So with this information we can go for writing cos Q. So cos Q is adjacent side of angle Q upon hypotenuse. It will give you QR upon PQ. Next ratio you have to write of tan P. Again P set, what we have did for sine ratio we can use. Tan definition is opposite side of angle P upon adjacent side of angle P, that is equal to QR upon PR. The last one, tan Q. Again we are coming back to Q. Opposite side of Q is PR, adjacent side of Q is QR. Tan ratio, opposite side of angle Q upon adjacent side of angle Q will be PR upon QR. The second example, in the right angle triangle XYZ, angle XYZ is equal to 90 degree and ABC are the lengths of the sides as shown in the figure. Write the following ratios: sin x, tan z, cos x and tan x. See, in the triangle XYZ, ABC are given the measures of the particular side. First we have to go for x. For x, opposite side is A. Adjacent side is B. And hypotenuse is C. So this is the raw material for making any ratio to write for angle X. So sin X, opposite side of angle X upon hypotenuse. First the ratio is being written in the name form, that is YZ upon XZ will give you A upon C. Same way if we go for the next, cos x, as for x already we have mentioned. So cos x will be adjacent side of x upon hypotenuse as per the definition of cos ratio. First ratio is being written in the form of sides xy upon xz, that will give you the value B upon C. Tan x, after that again it is related to x. Tan definition, opposite side upon adjacent side. The ratio we are writing for angle x, so it is particularly written that opposite side of angle x upon adjacent side of angle x. First answer is being written in the name format, that is yz upon xy, and value is equal to A upon B. Now only tan z we have to write. For that, the next example, triangle LMN, in a right angle triangle LMN, angle LMN is equal to 90 degree, angle L is equal to 50 degree and angle N is equal to 40 degree. Write the following ratios: sin 50, cos 50, tan 40 and cos 40. In this example, two more things we have to learn. One, that is we can write the ratios, and the second, if you observe the right angle triangle, M is 90 degree and we have two more acute angle in triangle LMN, that is angle L and angle N. So we can have the trigonometric ratios for angle L as well as for angle N, that is 40 degree angles for sin, cos and tan we can write, And for angle 50 degree L, also we can write the trigonometric ratios sine, cos and tan. Let us see the answer. Sine 50 for 50 degree, as per our method, first we have to select what is the opposite side for angle 50. It's MN. Opposite side MN. Adjacent side LN. And hypotenuse is LN. If we decide this, we find to write the ratio very easy. So sine 50 opposite side upon hypotenuse will be Mn upon Ln. Same way cos 50, as per definition, adjacent side upon hypotenuse, adjacent side of angle L is Lm, hypotenuse Ln. So the ratio is Lm upon Ln. Now 40 degree. For 40 degree, opposite side is Lm. Adjacent side is Mn. And hypotenuse doesn't change. So tan 40, as per definition, opposite side upon adjacent side will give you Lm upon Mn. Cos 40, adjacent side upon hypotenuse will give you Mn upon Ln.